Thus far, the videos of the 10-part whiteboard series have focused on what the characterization of the proposed strain of AI is, and why is it significant not only in regard to achieving a general variant of AI but also in enhancing the human theory of knowledge. The former involved alluding to disruptive modeling of intelligence while the latter invoked certain novel mathematical insights. Going forward, the emphasis of the videos will center around a high-level basis for a generic method to accomplish a more refined approach to technology and sciences, the how aspect of the research. This will embody as an understanding of object orientation, the most fundamental and inescapable constraint inherent to the human intellect. A philosophical overview of the proposed theory of mind, the omniject orientation. The omnijective cognitive architecture, a master blueprint that encapsulates any cognitive architecture ever conceived or is humanly conceivable. An understanding of the omniject and ensuing omnijectivity, and finally, an impact assessment as a summary of the transformative potential of the research, organized into the categories of technology, science, and philosophy. How exactly does the consequent method be applied in realizing general artificial intelligence? Wading through multitude of involved intricacies will be demonstrated as part of Project POC. Numerous cognitive architectures have been proposed since the beginning of modern research in cognitive modeling, spanning diversities of ideas, methods, disciplines, scopes, and relative success. Several comparative studies of these architectures were carried out over years as surveys, categorizations, and evaluations. Here, the fundamental concern common across the architectures is isolated, that inhibit development of a truly artificial and general intelligence, in the context of an extract derived of the acontextual model of cognition. The extract is comprised of 5 core conceptions, namely, the intelligence system, subject-object contract, potential semantic schema, heuristic subject-agent enablement, and the postulate of consistency over correctness. As will be seen, each of these notions is implicitly violated and offset by alternate narrower interpretations by every conceivable cognitive architecture. Though the commonality is drawn in reference to the prevailing architectures, it is in fact far deep-rooted in the very foundations of human cognitive process. Broadly, the limitations of the existing cognitive architectures get organized into programming-related deficiencies and knowledge modeling deficiencies. Human programming model does not allow for a separation of program contexts from the programmer contexts, with the comprising subject-object contract being implicit and always between the programmer and the programmable. Programs merely stage the act in the inevitable backdrop of the semantics resulting from programmer-programmable context fusion. This relegates the supposed intelligent agent to yet another object, a mere extension to the programmer's intelligence. Involved proxy contextualization invalidates any synthetic intelligence system and falls back onto the encompassing human intelligence system. Current-day architectures typically employ rules, both implicit and explicit, in a bid to abstract out program contexts. However, the emphasis of the rule extraction is not as much in providing non-default subject contexts to the programs as it is to model involved object subtleties, the underlying premise being that the intelligence exclusively resides within object representations. This line of thought trivializes both the intelligence system and subject-object contract postulates in case of any programmatic approach to AI. Further, given that the models of computation supported by our Turing machines are intrinsically algorithmic, programming has never been a heuristically enabling process of the programs. Knowledge modeling deficiencies. Knowledge representation formalisms such as rules, meta-rules, semantic networks spun over corpus of facts, domain ontologies, and extracted object patterns through training, etc., the staple seat of intelligence for current-day architectures, comprise eventualized forms of object semantics at different levels of abstraction. So modeled object characterization assumes a definite form and format outside the purview of the concerned synthetic agent before being put to use in generating intelligence. Consequent proxy eventualization mandates external intervention in terms of more human modeler element in scaling consequent intelligence, effectively containing general intelligence capabilities. Some eventualized forms of knowledge depiction, however, tend to be more fundamental than others in that they let programs scope eventualization to a limited extent. Representation learning methods and meta-rule-based AI, for instance, do produce finer-grained patterns of knowledge than were afforded but are otherwise confined in terms of indefinitely extensible eventualization and agent context explosion across domains. In general, the potential characterization of the semantic has not permeated the prevailing knowledge modeling paradigm. Given these limitations intrinsic to the method, human likeness of AI was traditionally sought in the consequence, irrespective of the adopted architectural approach, where emergent notion of correctness prevails over more fundamental consistency considerations of the ensued intelligence. However, a genuine intelligence such as human intellect thrives primarily on consistency, affording discretion to the subject agencies in determining correct from the incorrect, without requiring external feedback. All in all, achieving a truly general and artificial intelligence is constrained by the very acts of programming and knowledge modeling for the purpose, both operations being inherently complicit in the proxy mechanization of the synthetic intelligent agents. As explained earlier in the video number 5.2, adjectivization and acontextualization address the proxy contextualization and eventualization issues respectively in the proposed method. The umbrella term for the generic characterization of the human intellect that allows for human-specific cognition although limited by described deficiencies is what's called object orientation, termed as such in view of the nature of principal involvement. In materializing any cognition, such an orientation manifests as attributing an independent and absolute disposition to given phenomenon, the object. Vantage to the phenomenon, the human subject, and the comprised interfaces, such as, say, the human logic or sentience. On a philosophical note, this understanding encapsulates the essence of the cogito argument, the fundamental principle of René Descartes' philosophy that arguably provides certain foundations for the knowledge in the face of radical doubt. Object orientation relates to all human pursuit of structured knowledge, an approach that is inevitably marked by a supplementing deterministic intent of the involved subject agent towards given object entity, as both a means and an end. In the context of this video series, the deterministic intent chiefly gets typified by the algorithmic approach to programming. Thus, the method to overcome identified limitations is all about mitigating the inherent evils of algorithmic programming, being aware that the approach itself may not simply be wished away. To cite academic references, Husserl's idea of the phenomenological natural attitude offers the closest parallel to object orientation, though its rendition is essentially qualitative, limiting the operational possibilities. On the other hand, an appreciation of object orientation leads to a more operationally viable theory of mind, the omniject orientation, the topic for the next video of the series. Within the generic and encompassing contexts afforded by omniject orientation, some of the most abstract human cognitive faculties such as consciousness, discretion, ego, memory, identities and innate sensibilities etc. get rendered practicable in simulating the human intellect. Such an endeavor is riddled with numerous challenges that find a fresh operational footing, to name a few including Hegelian dialectics and the notion of self-consciousness, Kantian notions such as apperception and transcendental schemata, Heidegger's fundamental ontology and a host of continental philosophical ideas. Of course, conceiving the foundations for newer mathematics required, the omniject-oriented strain of it, in formulating the methodology forms the most formidable challenge of all.
A word of caution. Object orientation explained in this video may not be mistaken with the programming style that shares the name, the object-oriented programming paradigm supported by languages like Java, JavaScript, Python, etc. What's being talked of here is about the basis, not just for any specific class of programs, but for any human-coded program ever written. In fact, it's not just confined to the programs. The contention here is that all human cognitive activity is object-oriented. Our sciences are, our mathematics is. Underlying human logic is object-oriented. Evolution of our spoken languages follow the object-oriented pattern. Essentially, wherever the human mind is involved, the approach is bound to be oriented towards the object and its determination, perhaps supplemented by its creation. Every human did, right from the invention of wheel or discovery of fire, all the way to the invention of the internet, for example, or rocket sciences, or the latest buzz in the artificial intelligence industry, the generative architectures, and everything in between, irrespective of whether it's interpreted as being an instance of intelligence or of human stupidity. Everything, every human cognitive action, big or small, has followed this pattern. In other words, we had created innumerable objects since the time the human civilization started, but such a challenge as crafting a subject or subjective intelligence has never been ventured before. Incidentally, the last time the human sciences had to face a similar challenge, where the subjective element crept into the object conceptualizations of the microworld, the quantum phenomena, what with the observer effect, uncertainties, and observed realities, etc. The human mind came up with an ingenious workaround, which is to attribute a probabilistic character to the object. Basically, a problem that does not belong to the object-oriented realm was transformed to fit in. The problem statement itself was altered to allow for our inability to handle the subjective aspect. Instead, it's the reflection of the subject on the object side that gets captured statistically so as to provide practicability to the method. An extremely powerful operational pattern that's gone on to become gold standard, so to say, or a de facto practice in dealing with situations where the subject component may not be ignored. Trading, for example, econometrics, social network analysis, cephology. These are some of the fields, some of the domains where no modeling or analysis is possible unless the object is assigned a probabilistic character. Artificial intelligence as a field of study has joined this list with the advent of neural networks a couple of decades back, and there was no looking back. Synthetic bots that could beat the world chess champion, or the chat applications that could trick anybody into thinking they are interacting with humans, the so-called autonomous cars, the so-considered augmented realities. We are on the express highway of progress and evolution ever since. So, what exactly is the problem here? Why should we look anywhere else if we are making progress at unprecedented speeds? Firstly, because all the progress we see, the progress we experience, is with respect to an altered problem statement of artificial intelligence. None of our bleeding edge artificial intelligence technologies and their application respond to the original problem of an artificial source of intelligence. Instead, each of these is either a transformer or an adapter, most certainly an amplifier of human intelligence. The source, however, remains with the programmer's intelligence or the human mind behind it, the only known natural originator of intelligence. The point here is, we know how to create an object. We only know how to create an object, whereas intelligence is a characteristic of the subject. The reason why we could emulate the result of intelligence, a mere object in itself, but never could simulate the process of intelligence generation. The follow-up question would then be, does it matter? Should we really care about the distinction between emulation and simulation, particularly given the result emulation delivers, the entire body of current day artificial intelligence? If yes, what can be done? These are the questions that are going to be explored further in the next video. To summarize, object orientation refers to our natural attitude towards the external world, wherein the determinable, the object, the determiner, we ourselves, and the determination, our perception of the object, are all independent and absolute truths in themselves. This conviction powers the human intellect that's behind every civilizational advancement. But then there are some problems, a certain class of problems that do not yield to object orientation. The quest for a general variant of artificial intelligence being one such problem. This video explains why object orientation works against itself in attempting general artificial intelligence, and how every line of code you write and every rule you extract to model the object for the purpose of general intelligence takes you farther away from your goal. To complicate things further, object orientation is non-negotiable, meaning all human intellect comes to a standstill if we were to reject the basis of object orientation. That pretty much sums up the contents of this video. Please do provide your feedback and share the video if you find it interesting. Thank you.